Assalamualaikum and hi everyone. Today we will presenting our video presentation. Here are the members: Nurlisa Adrina, Nurul Alia Maisara, Nur Shafika and Shasha Nazira.
So first question, we are going to explain the meaning of differentiation and what are the technique of differentiation. So differentiation is the process of finding a derivative, which is it tells us how fast something is changing. In a graph, it shows the slope of a curve at any point, but in real life, it helps us understand speed, growth rate, and how things increase or decrease. Next is the technique of differentiation. Firstly is a power rule. So when we have x to the power of n, we will bring down the power and subtract 1. And the secondly, we have a constant rule, which is the derivative of a constant is 0. And the third one is a linear rule, which is the derivative of ax is just a. Okay, also we had a sum rule and difference rule. So sum rule is for two functions are added and we differentiate each separately. And difference rule same as sum rule, but it's for subtraction. And the last third is product rule, question rule, and chain rule. For product rule is used when two functions are multiplied, and for question rule used when dividing one function by another, and for chain rule used when one function is inside another.
Assalamualaikum and hi guys. Today I will be showing to you guys how to solve this question. The question is y equals to ln e to the power of 3x plus 4 over x squared minus 1. So the first thing that we need to know is what formula that we should use. In this case, we need to use formula quotient rule. VU prime minus UV prime over V squared. So right now we need to define which one is the U and which one is the V. So this one is U and this one is V. Okay, after that U is e to the power of 3x plus 4. Okay, right now we want to find U prime. How to find? We need to multiply e3x. We multiply this one. When we multiply, we will get 3e to the power of 3x. Okay, if we multiply numbers, we will get 0, so we don't need to write it. Okay, and then v is x squared minus 1. Okay, we differentiate x squared at 2x. We don't need to differentiate the minus 1. Okay, du over dx is equals to x squared minus 1 3e to the power of 3x, then minus e to the power of 3x plus 4 multiply with 2x over x squared minus 1 squared. Okay, after that we need to differentiate this one, ln. Differentiate ln. Okay, dy over dx, we write the equation. Okay, this one that we already differentiate, we need to multiply with du over dx that we write it before. This one multiply with du over dx. Okay, y over dx is equals to, okay, I put the x squared minus 1 at the top over e to the power of 3x plus 4, and then we multiply with du over dx. X squared minus 1 multiply 3e to the power of 3x minus e to the power of 3x plus 4 multiply with 2x over square minus 1 squared. Okay, after that we need to execute x2 minus 1 because it's the same number. Okay, so this one will become 0 and this one we have 1 here. Okay, now this is the final answer, so we just write the equation back. Y over dx is equals to x squared minus 1 close bracket open bracket 3e to the power of 3x minus e to the power of 3x plus 4 multiply with 2x. Okay, we write the e3x plus 4 again, okay? Because we don't execute it before, so we write it back. e3x plus 4, then x square minus 1. So this is our final answer. Okay, hope you are understanding.
Alright, so I'm gonna explain how to differentiate this function step by step. So as you can see, this is a fraction or known as a quotient. That means the function have a numerator and a denominator. So to differentiate it, we must use the quotient rule. Okay, so step 1, we need to identify the part of the quotient. So the numerator 1 is u equal to x to the power of 5 tangent 4x, and the denominator is v equal to 1 plus x squared. Alright, so from the quotient rule, in order to apply the rule, we need to differentiate the u and the v. Alright, so let's differentiate the numerator first, which is u equal to x to the power of 5 tangent 4x. So this is a product of two functions, which is x to the power of 5 and tangent 4x. So we need to use the product rule, which is u prime equal to u prime v plus u v prime. Okay, let's say u equal to x to the power of 5. So differentiation of u equal to 5x to the power of 4. So next, let's say v equal to tangent 4x. So the differentiation of v, since it's tangent of 4x, we must use the chain rule. So first step, the derivative of tangent x is secant square x. But because we have a derivative of the inside, which is 4, so we need to multiply it by 4 because of the inner function 4x. So v prime that we got equal to 4 secant square 4x. Alright, so after we substitute what we found, now we can plot them into the product rule. So u prime equals to 5x to the power of 4 times tangent of 4x plus 4x to the power of 5 times secant square of 4x. Okay, next we will find the differential of denominator. So v equals to 1 plus x squared. So v prime equal to 2x. So now we can plot them into the quotient rule formula. So the final answer that we got is dy per dx equals to open bracket 1 plus x squared close brackets times open bracket 5x to the power of 4 times tangent 4x plus 4x to the power of 5 times secant square 4x close bracket minus open bracket x to the power of 5 times tangent 4x close bracket times 2x. So all over open bracket 1 plus x squared squared.
Hi, Assalamualaikum everyone. In this video, I will explain how to find dy over dx using implicit differentiation for this equation. So, the equation that we got here is 3 sin xy minus e to the power of 2x plus y equal x squared. Since y is not isolate and appear inside both sign and exponent, we will use implicit differentiation. Step 1. We differentiate both sides with the respect to x. Let's start with the first term, 3 sin xy. The derivative of sin is cos, so we get 3 cos xy multiplied by the derivative of xy. Now, we apply the chain rule to xy. The derivative of xy is x times dy over dx plus y. So all together, this part become 3 cos xy multiplied by open bracket x dy over dx plus y close bracket. Now, let's move to the second term, e to the power of 2x plus y. We use the chain rule here. The derivative is e to the power of 2x plus y multiplied by open bracket 2 plus dy over dx close bracket. For the right hand side, the derivative of x squared is 2x. Now onto the step 2. We substitute everything into the equation and supposedly we got 3 cos xy multiplied by open bracket x dy over dx plus y close bracket minus e to the power of 2x plus y multiplied by open bracket 2 plus dy over dx close bracket equal 2x. Now, step 3. We expand the term. The first part becomes 3x cos xy times dy over dx plus 3
y cos xy. The second part become minus 2e to the power of 2x plus y minus e to the power of 2x plus y times dy over dx. All that equals 2x. Step 4. Now we group all the term that contains dy over dx on the left hand side and we get open bracket 3x cos xy minus e to the power of 2x plus y close bracket multiplied by dy over dx equals 2x minus 3y cos xy plus 2e to the power of 2x plus y. Now, final step is we solve for dy over dx by dividing both sides. So, the final answer is dy over dx equals 2x minus 3y cos xy plus 2e to the power of 2x plus y divided by 3x cos xy minus e to the power of 2x plus y. And that's how you find dy over dx using implicit differentiation when y is a part of trigonometric and exponential function. Thank you for watching.
Hi everyone, so next I'm gonna give the solution for this question 4, which is given fx equal to square root of 25 minus x squared. Use differentials to estimate value of square root of 25 minus in the bracket 2.9 square. And we need to give the answer in the correct 3 decimal places. For the first step, we need to determine the x. The function given here is square root of 25 minus in the bracket 2.9 square, so the x is 2.9. And then we need to state the value of x naught, which is here I choose number 3 because 3 is the nearest number to the 2.9. Second, we need to state the fx, which is the fx is square root of 25 minus x squared. It is equal to in the bracket of 25 minus x squared to the power of 1 over 2 because the square root is equal to 1 over 2. Third, we need to find the f prime x. We need to find the f prime x by differentiate the function. So, if we want to differentiate the function, the power must move at the front. And we rewrite back in the bracket of 25 minus x squared. After that, we need to differentiate again in the bracket so it becomes negative 2x at the back. The answer must be negative x in the bracket of 25 minus x squared to the power of negative 1 over 2. It is because the power must be minus with 1 and it becomes negative 1 over 2. Fourth, we need to find delta x, which is the formula is x minus x naught. For the x, here is 2.9. We minus with the x naught, which is 3, and it is equal to negative 0.1. Lastly, we need to substitute by use the formula given, which is f in the bracket of x naught plus delta x equal to f in the bracket of x naught plus f prime in the bracket of x naught multiplied by delta x. For the f, we take this function and then we substitute the 3 into the x naught plus with the f prime, we take this for the f prime and we substitute 3 into the x naught. After that, we multiply with the delta x, which is negative 0.1. It is equal to the 4 plus 0.075. We got the final answer, which is 4.075. It is in the correct 3 decimal places. So that's all from me. Hi everyone.
In conclusion, differentiation is a key concept in calculus that help us understand how values change. Using rules like the power, product, quotient, and chain rule, we can find how fast something changes at any point. It's useful in real life, such as finding speeds or acceleration, and prepare us for advanced math.